A rational function. A function f of the form f of x equals p of x over q of x, where p of x and q of x are polynomials, and q of x is not equal 0, is called a rational function. It's a ratio of one polynomial to the other. Some examples of rational functions are f of x equals 1 over x, f of x equals x plus 1 over 2x squared plus 5x minus 30, f of x equals 3x squared minus 3x minus 6 over x squared plus 8x plus 16. Since any values for which q of x equals 0 are excluded from the domain of a rational function, this type of function is often discontinuous. A discontinuous graph, that is, a graph that has one or more breaks in it. It's a graph that you cannot draw a connection continuously with your pencil. You have to break it up. Like for here, x equals 0 would not work, so x cannot equal 0. This factors into 2x minus 1 into x plus 3, and so x cannot equal 1/2 and x cannot equal -3. There have to be breaks there because that would make it 0. So that's an example of what I mean by the simplest rational function is the reciprocal function, 1 over x. The domain is the set of all real numbers except x equals 0. The number 0 can't be used for a value of x, but it's helpful to find some values very close to 0, for x very close to 0. We use the table feature on a graphing calculator here. So we have -1, -1/10, -100th, -1,000th, -10,000ths. And look what's happening to the y values. They're getting larger and larger. And if x is the positive side, they're also getting larger. Here they were getting smaller and smaller. Okay, let's go back. The domain of this function is a set of all real numbers except 0. The number 0 cannot be used for a value of x, but it's helpful to find some values that are close. So very close. We'll table featuring graphing calculator. So if we have x is on the negative side, -1, -1/10, -100th, -1,000th, etc., smaller and smaller, notice what's happening to the y value. They're getting more and more negative. So it looks like they're going to -infinity even. For the positive values, again, 1, 1/10, 100th, they're getting a larger and going to infinity. So what it looks like is happening is x gets closer and closer to 0. As x is going to 0, then the absolute value of y, or f of x, is going to infinity. The symbol x goes to 0 means x approaches 0 without necessarily being equal to 0. Since x cannot equal 0, the graph of f of x equals 1 over x can never intersect the vertical line x equals 0. This is called a vertical asymptote. On the other hand, as x gets larger and larger, the values of 1 over x get closer and closer to 0. So letting the absolute value of x get larger and larger without bound. So here we're letting x keep getting bigger and bigger. Y's are getting smaller and smaller. Causes the graph to move closer and closer, and this is called a horizontal asymptote then. So the reciprocal function here, 1 over x, the domain, since x cannot equal 0, is from -infinity to 0, union with 0 to infinity. The range, because of the horizontal asymptote, is also from -infinity to 0, union with 0 to infinity. Some points here were used, and it's decreasing all the time except for the break where x equals 0. It's discontinuous at x equals 0. It has a vertical asymptote here, and that's the y-axis, or x equals 0, and horizontal asymptote at the x-axis, or y equals 0. So the vertical axis was x equals 0, and the horizontal axis was y equals 0. Now we want to determine the domain and the intercepts for this. Well, basically, x cannot equal 0. So that means the domain is from negative infinity to 0, union with 0 to infinity. The intercepts, the x or the y-intercept is where x equals 0. So x equals 0 in here, it's undefined. So there is none. Y-intercept, there is none. The x-intercept, to find the x-intercept, you're looking for what's the x value when y equals 0. If you have 0 equals 4 over x, you can't do that. This 4, the only way that it equals 0 is if the numerator equals 0, and it can't happen. So there is also no x-intercept for this problem. So it is a little different. Okay, the domain, what would make the denominator equal to 0? Well, that would be x equals 3. So basically x cannot equal 3. And the domain is from negative infinity to 3, union with 3 to infinity. The y-intercept, so x equals 0, well, we filled in a 0, we'd have negative 1 over 0 minus 3, or we would have 1/3. So the y-intercept is 1/3. For the x-intercept, where y equals 0, we run into the same problem we did with the last one. We have 1 over, and we can't have that. We're going to end up with none again. There is no x-intercept.